Understand IPSec site-to-site VPN. So do you understand what is VPN or virtual private network in general? Forget about IPSec site-to-site. We will understand IPSec site-to-site also. But let's first understand what is VPN, because VPN not always necessarily means encryption. VPN could be any tunneling technology to extend private networks over shared network infrastructure. So let's understand like what is tunneling technology, what is VPN, like and different types of VPN. Then we will understand IPSec in detail, right? IPSec framework, because IPSec is ITF standard framework. So we will understand IPSec framework in detail about policy-based VPN, route-based VPN, IKE phase 1, IKE phase 2 negotiation. We will understand everything in this section, right? ESP, AH. But first thing first, so first let's understand what is tunneling technology. VPN or virtual private network means is a tunneling technology that extends private networks over shared network infrastructure. Shared network infrastructure. And VPN is not always or necessarily means encryption, right? Let me quickly give you examples wherein like encryption is not done by default. So if I take example of like GRE tunnel, because GRE tunnel is again a VPN, virtual private network, layer 3 VPN rather I would say, right? Or MPLS VPN, even IPSec is also like example of VPN. And layer 2 VPNs, so layer 2 VPNs like virtual private LAN service, Metro Ethernet, very legacy WAN technology, that is frame relay, is again example of layer 2. Or layer 2 tunneling protocol is again layer 2 VPNs, etc. So VPNs could be either layer 3 or layer 2, and in layer 3 like common most like example is GRE tunnel, generic routing encapsulation. So let's understand what is tunneling technology exactly. What do we mean by like tunneling technology, and then we will understand IPSec site-to-site VPN, right? So tunneling means like encapsulation, right? For example, let me take one example to make my point more clear. So here if there is one router R1, another router R2 in the middle of communication stream, and R3 is the destination router, and network here is 30 network 30.0.0 and source or sender is 10.0.0.0. Objective is to ensure routing between both networks, right? Both networks means 10.0.0.0 and 30.0.0.0. That's the objective, right? We want IP reachability between both networks, 10 and 30. Of course, like we have access of both R1 and R3, and let us assume R1 has like proper routing information for 30 network, R3 has routing information for the 10 network, but R2 in the middle like doesn't have any routing information about 10 or 30 network, right? So you understand routing is always hop by hop routing. So even if R1 has information about 30 network and also directly connected 10, and maybe segment like between R1 and R2, let's say this one, right? 12.0.0.1 and here 12.0.0.2. R3 also has routing information about 10 network, remote network, I mean also locally connected networks 30 and 23003. 23 is here and 23002 is here, right? So I hope you understand now the like routing information of both R1 and R3. Now I have a space here. Okay. All right. So now what happens like, and R2 has only information about both directly connected networks 12 and 23, both directly connected network, right? But routing is hop by hop. So if R1 sends like packet to R2 sourcing any IP from the 10 network and destination 10 network and destination 30 network. So what happens when packet reaches R2? R2 will perform routing table lookup. Do I have route for 30 network? Unfortunately not, right? So there is no routing further. Either R2 will send ICMP unreachable message, or maybe packet will be silently dropped here. So in order to make that happen, in order to ensure IP reachability between R1 and R3, means like connected networks, network connected to R1 and R3, either R2 should have routing information proper, means R2 should have like route for 10 network and as well as 30 network, right? And another option is what? Another option is creating tunnel, GRE tunnel, okay? Tunnel between R1 and R3, this way, okay? And routing packet via tunnel interface, GRE tunnel, I mean, right? So what happens when we create GRE tunnel? Then we specify tunnel source address from R1 perspective, tunnel source is 12001 and tunnel destination address. Tunnel destination address is 23003. And then we change routing information. We put route for 30 network via tunnel interface, right? GRE tunnel or tunnel interface IP address. So routing is changed, tunnel is created with tunnel source and tunnel destination. So what happens now? Again, packet is routed via the same physical path, right? Physical path means R1 to R2. But now what happens now? Tunneling means now packet is encapsulated. Further encapsulated, extra layers are added. Means in case of ICMP packet, ping packet, IP header and ICMP original packet. So original packet means source IP, let us assume 10001 and destination IP 30001. So what happens here? In case of GRE tunnel, two extra headers are added, GRE header and new IP header. And new IP header means source IP, tunnel source IP address, and destination IP means tunnel destination address, right? So once packet reaches R2, so R2 will look at the outermost IP header, not the original or internal IP header, right? Because original packet is encapsulated. So R2 will now look at the outermost IP header. What is destination address? 23003. Do I have route for 23003? Yes, 23 is directly connected network segment. So this way packet is successfully routed to R3. And that's what tunneling is or encapsulation is. So tunneling means adding extra header, right? Original packet is tunneled. So I hope you understand what is tunneling or GRE tunnel. So it's one of the example of VPN. But what is IPSec side-to-side VPN then, right? And how IPSec side-to-side VPN is different than the GRE tunnel. So first understand, like side-to-side VPN means connecting different sites or multiple locations using shared network infrastructure. So for example, here if there is one site here, site A or site 1, right, and site 2 is far away from site 1, remote site, remote location, right? Maybe site 1 is in India somewhere, site 2 is in USA somewhere. And what is objective? Objective is to extend private networks, right? Means connecting both sites together, site 1 and site 2. Maybe site 1 network address here is 10.0.0/8 and site 2 network address 172.16.0.0/16, private networks of course. So objective is to ensure IP reachability between both networks, 172.16 and 10 network, private network. So whole bunch of like servers, applications, Windows devices, and we want to connect both sides, right? Maybe 2 different cities in the same country or different countries even, and not only 2 even, there could be more than 2 locations even. So one of the option like is like connecting both sides with dedicated P2P circuit, point-to-point connections, or maybe MPLS service or Metro Ethernet, right? Any WAN technology provided by telecommunication service provider. But whenever we opt for that, like P2P circuit or point-to-point lease circuit or international private lease circuit or national lease circuit, so there are a lot of challenges. First challenge here would be like the feasibility. If company approaches one of the service provider or telecommunication service provider for maybe 1 gig P2P circuit, point-to-point connection between 2 locations, then service provider will first check the feasibility, whether both sides, both locations are feasible or not. I mean like whether ISP has any nearby exchange or point of presence to do the connectivity or not, right? And if like there is feasibility, then like provisioning is done, and this may take like 10 to 15 days, very expensive, it's not cost effective solution. And what happens when there is another site, another location, another office, now requirement is to connect third location with existing 2 sites, then again the same challenge, right? First like feasibility check, then like provisioning, connectivity is like it's not very quick, and it is always subjected to the feasibility, very expensive, but at the same time secure, right? Because it's a private lease circuit, you can assume as if you have like connected both locations with dedicated cable, P2P or point-to-point lease circuit, right? So it's like a big challenge, but at the same time very secure because it's a private lease circuit, there is no internet here. But as I said, is always subjected to feasibility, very expensive, one-time cost, recurring charges, and it is not very scalable solution, right? So other option, other solution here is IPSec site to site VPN. Means if there is one site here, there is another site, VPN gateway 2. So we can even use internet as the transport to connect both sites, both locations. So here internet is what? Internet is the public network and transport here. And you understand like internet is everywhere, very cost effective, good data transfer rate. In fact nowadays even site can have even business broadband, internet lease line circuit, or any type of VPN connectivity. Not necessarily VPN has to be lease line internet connection only. Requirement here is just internet connection. So if both sides like have internet reachability, connectivity, then on top of that we can configure IPSec tunnel, right? IPSec tunnel. So this way private network is extended. So network here 10.0.0.0, network behind gateway to 172.16.0. objective is to protect both networks, right? And ensure reachability between both networks using internet as the transport. Yes, possible with IPSec site to site VPN, because in IPSec what happens, not only encapsulation is done, even data is like encrypted, data integrity check, anti-replay, and data origin authentication, because IPSec itself is an internet engineering task force, a standard framework for data encryption to ensure that data is confidential. Data integrity check means like during transit data is not tampered. Anti-replay means like not accepting duplicate packets with the same sequence number. And data origin authentication, right? So IPSec VPN is different than the MPLS or GRE or any other VPN technology, because in IPSec not only the data is encrypted, the packet typing is encrypted, extra headers are added. So if we use a protocol, ESP is one of the IPSec protocol and very important protocol. Other option is AH, but AH is not used. I will explain about ESP later on. Encapsulating security payload. So if ESP is the protocol, so ESP header is added, new IP header is added, and also ESP tailor and ESP auth. So original packet is encapsulated, encrypted, right? And data integrity is also checked. Anti-replay mechanism, data origin authentication is all done because of IPSec, because IPSec is a ITF standard framework, right? So very with some configuration we can securely connect both sides using internet as a transport. And you understand, internet is the transport. That means in case even if there are like 10 sites, 20 sites, 40 locations, 40 sites, so yes, we can connect those location sites with IPSec tunnel. If we want, then we can go with full mesh topology, full mesh, or maybe partial mesh or hub and spoke. But connecting different sites, different locations with IPSec is not very complex, right? So with the help of IPSec VPN, we can like provision like WAN connectivity across different sites, different locations. And if really you want to minimize configuration, you want this tunnel, IPSec tunnel, to build dynamically on demand with minimum configuration in the full mesh, hub and spoke, right? So you can use SD-WAN technology, software defined WAN, because SD-WAN, in SD-WAN what happens, like sites are like connected with same IPSec tunnel, right? IPSec tunnel, but with minimum configuration or maybe no configuration at all. On-demand tunnel negotiation is done in SD-WAN, apart from some other benefits like application-aware routing, performance-based routing, controller-based solution, easy to manage wide area network, right? A lot of benefits of SD-WAN, but the behind the scene IPSec tunnels are created. So if there are 3 or 4 sites, we want like full mesh connectivity across all the 4 sites, right? Using internet as the transport, yes, possible, right? Full mesh connectivity, tunnels are created automatically or maybe with very minimum configuration. Okay, so IPSec tunnel or IPSec site-to-site VPN means like connecting different sites, different locations with IPSec, because encryption alone cannot provide complete security. You understand that, right? Tunneling, and then on top of that encryption means if data is encrypted or packet is encrypted, right, extra headers are added. So encryption alone cannot provide complete security, because data can be like maybe headers are not encrypted, of course. So what if like there is change in the header, like sequence number for example here is modified, change, maybe a replica of the packet is created and sent to the same destination, right? Duplicate packets kind of stuff. So there has to be some mechanism to like provide complete security, and that is why in IPSec not only encryption is done, of course encryption is done, right, but apart from encryption, data integrity check or hashing algorithm, NT replay, wherein like sequence number, one of the important attribute of ESP header, plays very important role, and also data origin authentication, right? So IPSec means complete security, because internet, you understand, is a public network, is not a secure network. In fact, that's why like encryption, data integrity, NT replay, and data origin authentication all would be required. Drawback of IPSec side-to-side VPN is something, size of original packet is increased, right? So if MQ is not properly set, then this may lead to fragmentation, CPU utilization will be increased because of that, and also like encryption and decryption again like will impact performance of the device, throughput of the device. So it's one of the drawback of IPSec side-to-side VPN. And of course security and IPSec configuration should be correct. In fact, right, the lifetime of key negotiation and all that configuration, we'll understand that how like rest of the things are done.